Yes, ma'am.
So now, under this topic as a magnetic material, now we are going to concentrate on origin of magnetism. Now, for this origin of magnetism, we can consider a substance, any substance. This substance is made up of number of atoms, and every atom consists of number of electrons. And when we are going to concentrate on this atomic structure of any substance, so your atomic structure is that is at the center of atom there is a nucleus, and around this nucleus these electrons are revolving around the nucleus. Like in first orbit, number of electrons are 2. As your number of orbit will goes on increasing, the holding capacity of the electron will also goes on increasing. That's your mind. Clear? So now, for every atom, electrons are present, and these electrons are revolving in the orbit. Clear? Now, when these electrons are revolving in the orbit, in chemistry you have seen Pauli's exclusive principle. And in that Pauli's exclusive principle, you are knowing that no two electrons have same spin number. Right? तो आपका sp-d ऑर्बिट कंसेप्ट आपको पता है, Pauli's principle पता है, no two electron have the same spin number, इसलिए आपका spin number पॉजिटिव नेगेटिव हाफ रहता है. अगर एक इलेक्ट्रॉन को पॉजिटिव हाफ है तो दूसरे इलेक्ट्रॉन को नेगेटिव हाफ रहेगा. So according to that, the rotation of electron will goes on changing. ये सारी चीजें आपने केमिस्ट्री में पढ़ी. Right? Now, what we are going to consider that is अगर वहाँ पे if in the outermost orbit of the electron there are insufficient electrons. Insufficient electron इसका मतलब है that you are knowing that to become the stable orbit, minimally there should be a requirement of 8 electrons. अगर 8 इलेक्ट्रॉन से कम इलेक्ट्रॉन ऑर्बिट में है, then that orbit will be become as an unstable orbit. If we are considering such unstable orbit, suppose मैंने बोला वहाँ पे 6 इलेक्ट्रॉन्स हैं, या वहाँ पे 7 इलेक्ट्रॉन्स हैं, 6 या 7 इलेक्ट्रॉन्स हैं, इसे पकड़ लीजिए. Is it right? So what happens there? This outermost orbit becomes as an unstable orbit. And in unstable orbit में जो electrons हैं, these electrons are responsible for the property of your magnetism. Fine? Now electron का motion कैसे होता है? आपको पता है. When electron is revolving in the orbit, it is performing a orbital motion. So every electron has a two type of motion. One is a orbital motion, and at the same time that electron is spinning around itself. So there is a spin motion. Like our Earth. Earth is rotating around the sun in the orbital path, and Earth is also rotating around itself. That is the spin motion. Similarly, the electron has these two motions, orbital motion and spin motion. Now when electron is performing a orbital motion, जब कोई भी इलेक्ट्रॉन ऑर्बिटल मोशन परफॉर्म करता है, तो लेट्स कंसीडर फर्स्ट ऑर्बिट. when electron is performing a orbital motion, at that time अगर मैंने इस एरो से आपका इलेक्ट्रॉन का मोशन दिखा है एंटी क्लॉकवाइज, तो इलेक्ट्रॉन्स आर मूविंग इन द एंटी क्लॉकवाइज मैनर. इसका मतलब है उस ऑर्बिट में करंट फ्लो हो रहा है एंड द फ्लो ऑफ करंट इज इन द क्लॉकवाइज. क्लियर? मींस ये जो आपका ऑर्बिट है इलेक्ट्रॉन ऑर्बिट, दैट इलेक्ट्रॉन ऑर्बिट will act as a current loop. So electron orbit will act as a current loop. उसमें current flow होगा, and when current is flowing through a circular loop, so it will be act as a current loop, and that current loop has a magnetic moment. That current loop has an orbital magnetic moment, which is nothing but I into A. Why? I is the current flowing through that loop. A is nothing but the area of loop. Actually, there is an N. N is nothing but the number of turns of that loop. लेकिन यहाँ पे एक सिंगल लूप है. Single loop means number of turns. N is equal to 1. Therefore, your magnetic moment associated with this current loop is nothing but I into A. So there is an orbital magnetic moment. At the same time, that electron has a spinning motion. वो spin हो रहा है. Spin हो रहा means what? It is performing a rotational motion. And whenever it is performing a rotational motion means again a current loop. So with that spin motion, a magnetic moment is associated, which will be indicated as a ms. So orbital moment, magnetic moment is a vector quantity. Spin magnetic moment is also a vector. The spin magnetic moment is what? That is spinning. Spinning means rotational motion. अगर वहाँ पे rotational motion है, इसका मतलब वहाँ पे angular momentum. So electron is associated with angular momentum, and that associated angular momentum will give us a magnetic moment. इसका मतलब क्या है? As the electron has two types of motion, that electron has two types of magnetic moment. Which two types? One is orbital magnetic moment, which is nothing but I into A, and another is nothing but the spin magnetic moment. So what I can say that, therefore I can say that the total magnetic moment of an single electron is nothing but the vector sum of orbital magnetic moment and spin magnetic moment. And due to this magnetic moment, that substance, that atom has a property of magnetism. Clear? So property of magnetism किसकी वजह से? Orbital magnetic moment, spin magnetic. ये orbital magnetic moment, spin magnetic moment क्यों है? Because electron has a two types of motion. इसका मतलब origin of electron is what? Revolving electron. अगर आपका इलेक्ट्रॉन रिवॉल्व नहीं होगा तो ऑर्बिटल मोशन नहीं होगा. ऑर्बिटल मोशन नहीं होगा तो ऑर्बिटल मोमेंट नहीं होगा. स्पिन मोशन नहीं होगा तो स्पिन मोमेंट नहीं होगा. इसका मतलब योर रिवॉल्विंग इलेक्ट्रॉन इज फुल्ली रिस्पॉन्सिबल फॉर ऑर्बिटल मैग्नेटिक मोमेंट एज वेल एज फॉर स्पिन मैग्नेटिक मोमेंट. एंड दीज टू मैग्नेटिक मोमेंट्स gives rise to a property which is to be called as your magnetism. So in short, what I can say that is the origin of magnetism is nothing but your revolving electron. The revolving electron is responsible to produce the property which is to be called as a magnetism. Clear? तो यहाँ पे आपका 2 मार्क का क्वेश्चन. Explain origin of magnetism. I will again repeat. The substance is said to be magnetic because that substance has a number of atoms. Every atom has number of electrons. Every electron in the orbit has a two types of motion. One is orbital motion, second is the spin motion. When electron is moving in the orbit, means a current is flowing in that orbit, and your orbit is circular. So your motion of electron gives rise to a current loop, and every current loop has a magnetic moment, which has a basic formula: current area of the loop into number of turns. लेकिन अगर मैंने फर्स्ट ऑर्बिट के इलेक्ट्रॉन्स लिए तो ऑर्बिट नंबर 1, उसके नंबर ऑफ लूप्स भी 1 है, तो दिस n is equal to 1. So this orbital magnetic moment has a magnitude I into A. At the same time, that electron has a spin motion. motion. Spin motion means electron is rotating. It is rotating with angular momentum is associated with it. And that angular momentum will give us a magnetic moment. इसका मतलब electron has two types of momentum. One is orbital magnetic momentum, another is spin magnetic. And hence, the named magnetic momentum of every electron is nothing but the vector sum of orbital magnetic moment and spin magnetic. And due to this magnetic moment, there is a property which is to be called as rho. And hence I can say that for magnetism property, revolving electron is responsible. So I can say that origin of magnetism is nothing but the revolving electron. Clear? Now, once we are saying that is origin of electron, origin of magnetism is a revolving electron, then automatically our next topic will start. Then what will be the magnetic moment associated with revolving electron? Now, magnetic moment associated with revolving electron is what I want to find out, orbital magnetic moment. So, this orbital magnetic moment is nothing but your vector MO, which is associated with revolving electron. So, what is the derivation of that? Clear? For that, I can consider a nucleus of an atom at the center, and around the nucleus, suppose I am saying that there is one electron is revolving, only one electron is revolving. Here then one single electron is revolving, means it gives rise to a current. So यहाँ पे मेरा current नहीं. Is it right? So what I can say that, therefore I can say that magnetic moment, orbital magnetic moment associated with this current is equal to nothing but I into T. The original one. Clear? In that, what is that? This R is nothing but the current, and this A is nothing but the area of that. Now, for this loop, if I am saying that R is the radius of this current loop, then for this A, I can write the formula pi r square, that is the area of current loop. Clear? Then, now I can write down for this current. Clear? Now to write for this current, I can take the help of current definition. Current I is nothing but your charge upon time, rate of flow of charge with respect to time. Clear? Here, charge is nothing but electron. So I can replace Q by E, so it is C by T. So what I am getting? Current I is equal to E upon. Fine? Now, if I am saying that here is one electron and this electron is taking time capital T to complete one revolution. So what I can say that period of that electron is capital T. So this T I can replace by capital T. That is, I am getting one constituent current if electron will complete one revolution. And when electron will complete one revolution, the time taken during that process is nothing but the capital. यहाँ पे मुझे capital. Is it right? Now, I will replace this capital T with the help of velocity of electron. When this electron is revolving, means that electron must have a certain velocity. This electron in one revolution, complete a distance which is equal to the circumference of this current loop. So circumference of that current loop is nothing but the distance covered. Means what I can say that distance covered, which is equal to 2 pi r. because r is a irreducible. So I get the definition of velocity. Velocity v is equal to distance upon time. Basic definition. Distance covered in one revolution is 2 pi r divided by time taken in one revolution is t. Fine. So I write for period. T is equal to 2 pi r upon v. This is the value of your t. Now this value of period I can substitute in the current equation. Yeah. So if I substitute that, I will get current I is equal to E divided by T. T क्या है आपका 2 pi r and V will go to numerator. So I am getting this as well. Clear? Now using this current equation, now I can find out this orbital magnetic moment. So now what that orbital magnetic moment? MO is equal to I into E. बराबर? मेरे पास I वैल्यू है, so I'll put that I value is E V upon 2 pi r. This is the value of I. Into A. A is what? Area of the loop. So area of the loop आपका क्या है? Pi r square. Fine. So this pi factor will get cancelled. One of the r factor will also get cancelled. And now what I am getting is equal to EVR upon T is nothing but your orbital magnetic moment of an electron. So this is nothing but your derivation for orbital magnetic moment of a revolving electron or magnetic moment of a revolving electron. तो ये हो गया आपका डेरिवेशन फॉर फिजिक्स. क्लियर? कहाँ से स्टार्ट किया? रोटेशन ऑफ इलेक्ट्रॉन. रोटेशन ऑफ इलेक्ट्रॉन गिव्स करंट लूप. करंट लूप का द मैग्नेटिक मोमेंट I into A. इसमें हमने A and I के वैल्यू सब्स्टिट्यूट किए and then I am getting this momentum, magnetic momentum of an revolving electron, which is equal to nothing but EVR upon 2. ये हो गया एक फॉर्मूला. नाउ इसको इस फॉर्मूला को हम मॉडिफाई करेंगे. व्हाट इज दैट मॉडिफिकेशन? बेसिक फॉर्मूला है हमारा ऑर्बिटल मैग्नेटिक मोमेंट इज इक्वल टू EVR अपॉन 2. इसमें आई सब्स्टिट्यूट V. इलेक्ट्रॉन इज परफॉर्मिंग ए रोटेशनल ऑर्बिटल मोशन. ऑर्बिटल मोशन इज व्हाट? सर्कुलर मोशन. और हमने सर्कुलर मोशन में देखा है V is equal to R omega. Right? So instead of V, I can put R omega. So I'll get orbital magnetic moment is equal to E R square omega upon 2. Right? और एक फॉर्मूला E R square omega की जगह 2 pi f upon 2. तो ये आ गया मेरा orbital moment in the form of frequency. Or instead of frequency, I can write down E R square. They 2 factor cancel multiplied by pi, and instead of f, I say 1 by 2. तो ये हो गया मेरा और एक orbital magnetic moment. Clear? So these are the 4 formulas for your orbital magnetic moment of an revolving. बेसिक फॉर्मूला था मैग्नेटिक मोमेंटम का EVR अपॉन 2. उसमें हमने सब्स्टिट्यूशन करके और चेंज करना. ये टेक्स्ट बुक में नहीं है, बट देयर आर न्यूमेरिकल प्रॉब्लम और देयर आर सम वेरी शॉर्ट आंसर फॉर MCQ क्वेश्चंस. दैट्स व्हाई यू हैव टू कंसंट्रेट ऑन दिस मॉडिफाइड फॉर्मूला. तो मॉडिफाइड फॉर्मूला करते टाइम हमने as electron is performing a rotation revolving motion का मतलब है circular motion. तो इसलिए फिर हमने circular motion को फॉर्मूला यूज किया. और इस circular motion में V is equal to R omega. तो वो फॉर्मूला यूज किया and we have found out the different things. गॉट इट? तो ये सारे फॉर्मूले आपको बहुत अच्छी तरह से याद करने हैं। ये फॉर्मूला आपकी बुक में है, बट दीज फॉर्मूलाज आर नॉट देयर। One is in terms of omega, second is in terms of frequency, third is in terms of period of time. Clear? तो इसीलिए ये अच्छी तरह से मुद्दा है। फाइन, तो ये हो गया आपका सेकंड क्वेश्चन। गॉट इट? नाउ I can go for the third question. What is that third question is there? That is when I am saying that is electron is performing the circular motion, that is orbital motion. At the same time, electron is performing a spinning motion. Spinning motion का मतलब है your electron is performing a rotational motion. So during spinning motion, electron is rotating. Electron is rotating means what? That electron has a angular momentum. And this angular momentum is denoted by letter L. And you have seen in your first chapter, rotational dynamics, angular momentum L is equal to I into omega. I is what? Moment of inertia. Right? Now moment of inertia what? Electron. आपका single electron that will be revolving in the orbit. तो यहाँ पे देखिए, nucleus, electron is revolving in the orbit. This electron has a mass m. It is revolving in the orbit of radius. So what I can say that its moment of inertia. Moment of inertia is product of mass into square of distance from axis of rotation. So I का value आ गया m square. And as this I value is your mr square, I value is mr square, omega के लिए I will substitute v by r. And this m is the mass of electron. I can replace it by me. Me is the mass of electron. So what I am getting that angular momentum is nothing but me r into v. This is nothing but the angular momentum of electron when that electron is performing a spinning motion. Right? Now, this spinning motion of electron and this orbital moment, I can relate this both the quantities. Just concentrate. Angular momentum and orbital moment. These two quantities I am going to relate with. How? Just concentrate. ये आपका orbital magnetic moment है. MO is equal to EVR upon 2. अगर इस इक्वेशन को मैंने न्यूमरेटर एंड डिनोमिनेटर को मल्टीप्लाइड बाय मास ऑफ इलेक्ट्रॉन किया, ये देखिए Me multiplied divide to which equation? EVR upon 2. Is it right? So I write down here. What I write down? Rewrite ER. MERV. Right? This is in one term. Into bracket. बचा हुआ क्या? E divided by 2 ME. ये बचा. लेकिन ये quantity MEVR, this quantity is nothing but your angular momentum. So what I say that it is equal to, इसके लिए हम लोग क्या सब्स्टिट्यूट करेंगे? L. So L into bracket E divided by 2 ME is equal to nothing but your MO. So this I am getting relation between orbital moment and angular moment. Electron का angular momentum क्यों है? Electron has angular momentum due to its spinning motion. और फिर हमने angular momentum and rotational moment की magnetic moment, both are related by this formula. Is it right? Now, if I will check, that is MO upon L. MO is what? Orbital magnetic moment divided by angular momentum of electron. This ratio is to be called as a barometric ratio of electron. So ratio of orbital magnetic moment to angular momentum of electron is called as a barometric ratio, and here I am getting your barometric ratio MO by ML by this formula. L को यहाँ पे डिवीजन के लिए लिया. Hello student, are you getting?
Yes, ma'am.
Yes, ma'am.
So this ratio of MO by L, this ratio of MO by L, this ratio I am writing as a E divided by 2ME. Clear? अगर ये रेशियो मेरा वो है, तो what I say that E is the charge of electron, which is equal to 1.6 into 10 raised to minus 19 divided by 2 multiplied by mass of electron. Mass of electron 9.11 into 10 raised to minus 39. So I am knowing the constant value. So I can do that constant value calculation. So I'll do that constant value calculation and I can find out the value of this barometric. Clear? So up till this, today I am going to take in this lecture. The remaining part you can see in the next lecture. Fine? Okay. Now tell me, any doubt you have here? मैंने रिकॉर्डिंग स्टॉप कर दिया है, बात करो अभी.